Hi everyone, welcome to lesson 3. We are going to begin the part of the unit where we are solving quadratics using different methods. Today we are going to focus on solving quadratics using the square root method. So typically the format of our quadratic function will be in the form ax squared plus c equals 0. This is when there is no x term in the quadratic equation and you can solve using the b method. Remember, when there's no x term, there is no b in this case. So step 1 is to isolate the x squared. You want to get that term completely alone. Step 2, we are going to take the square root on both sides of the equation. Remember, in any equation, whatever you do to one side of the equal sign, you must do on the other side so that way it stays balanced. Now let's take a look at an example together. We are given the quadratic equation x squared minus 64 equals to 0. Remember, step 1 is to always isolate that x squared, so I'm going to add 64 to both sides. After adding 64 to both sides, I'm left with x squared equals to positive 64. Step 2 is to then take the square root of both sides to cancel out that x squared. Remember, when you take the square root of a perfect square, you are left with a positive root and a negative root. Remember, 64 is a perfect square, so you'll notice that x equals positive and negative 8. Now, there are two different ways that you can write your answers. You can write that x equals positive or negative 8, or you can list them in set builder's notation, and remember that means that we use brackets and we put the solutions in order from least to greatest. I'd like you to pause this video after I give you the following directions. I'd like you to solve problems 1 through 9 on the notes provided. I'd like you to solve each of these quadratic equations using the square root method. If you end up with a radical that is not a perfect square, I'd like you to simplify the radical. Do not round to the nearest tenth. You may pause the video and get started now. Now, here are the answers for problems 1 through 6. Sometimes, like in example 2, you will need to do 2 steps in order to isolate the x squared term. Remember, in order to isolate the x squared term, we use inverse operations. In example 3, you'll notice that we are left with the fraction 25 over 4 before we take the square root. Remember, back when we learned about radicals in the beginning of the year, you may take the square root of a fraction as long as that fraction has perfect squares in both the numerator and the denominator. And that happens to be the case in problem number 3. Now let's take a look at the solutions to problems 7, 8, and 9. Now let's take a look at problem number 7. I'd like you to star problem number 7. Notice that after isolating the x squared term, you're left with x squared is equal to negative 6. When you take the square root of a negative number, you get an imaginary number. In this case, anytime you get the square root of a negative, all you need to say is that your solution is no real roots. Number 8 is pretty straightforward. As for number 9, notice that the square root of 20 does not give us the square root of a perfect square. This is where you need to tap back into what you learned earlier in the year and simplify the radical. When simplifying the radical, you find that it simplifies to 2 rad 5. In this case, it still has a positive and a negative root, and you can leave it as x equals plus or minus 2 times radical 5. Now, I did not assign you to do problems 10, 11, and 12, but if you would like to, you may do so for practice. Okay, now we are going to do some application problems using the square root method. We are going to deal with the falling object model. In this case, anytime you see H, that represents our ground level in the problem. The variable t will represent time. The variable s in this case will be our initial height of the object. Now let's take a look at our first word problem together. Before we get started, I just want to remind you that in a word problem, we will only be using the positive solution or the positive root in this case. Remember that time cannot be negative. Now let's take a look at problem 13. Sarah drops an egg from a height of 42 feet off the ground. How long does it take for the egg to hit the ground? In this case, the ground level is 0 or 0 feet. However, we do know that the initial height in this case is 42 feet. Using the model h equals negative 16 t squared plus s, we can fill in 0 for h and 42 for feet. Now we are going to solve using the square root method. First, we will subtract 42 over, so we have negative 42 equals to negative 16 t squared. We're going to continue to isolate the t squared value. So in this case, when we divide negative 42 with negative 16, we get the decimal 2.625 is equal to t squared. Then we will take the square root. Remember, we only want the positive root. So in this case, it's going to be equal to 1 62/100. So since this is a word problem, we just quickly need to say a short little sentence to answer the question. We can quickly say it will take the egg to hit the ground after approximately 1.62 seconds. Now let's take a look at example 14. Ella is walking across a bridge and accidentally drops her watch. The bridge is 80 feet above the water. How long does it take for her watch to reach the water? Please pause the video and give this a try on your own. In this case, she should have found that the ground level is 0 and the initial height is 80. After solving using the square root method, it will take her watch about 2 24/100 seconds to hit the water. This is all for lesson 3. Please go back to my teacher page and continue on with the practice and the exit ticket. See you next time.